Okay. I come along 1, 2, 3, 4, 5, 6. What's the average?
By what?
1, 2, 3, 4, 5, 6. So what's my
3.5
average? What did you say?
3.5.
3.5.
I think we did this last.
In other words, they're
You didn't
symmetrical. So what's the middle of 1, 2, 3, 4, 5 and 6 is 3.5. How do you do it properly?
Yeah.
The mean is 1 plus 2 plus 3 plus 4 plus 5 plus 6. Over?
6.
6. So we've got, what have we got? We've got 10, 20,
It's a middle.
21 over 6, which is
3.5.
3.5.
I used to.
But if we have it as a probability table, remember this is the stupidest, most simplest case we can do. You can come back to me. The simplest case we can possibly do to get you the concept, so you can do it much harder and more annoying, putting K's and all sorts of weird wacko things that muck people up. What's the probability of getting the 1? 1, 6.
What about 6?
1, 6.
No,
1,
just
6.
have the two
1,
numbers.
6.
Yeah.
So, before I forget, what sort of distribution is that called? Starts with U. N. Uniform. So it's a uniform. What's a uniform mean?
It's the same.
1, 4.
Everything is
It's like,
The same.
equally or the same. Equally likely. Everything's equally likely. So that one's as likely as that one, which is as likely as that one. And anything you can do. You can look at the clock and with the clock going around, but that's continuous. And you can say the chance of it being between 12 and 1 is the same as it being between 1 and 2, which is the same as it being between 2 and 3. It's a uniform probability. I actually have a solar panel meter out the back, and it goes through a cycle of about 10 things. And sometimes I want to walk out and see how much I'm getting at the moment. I haven't done it for a while. And you walk out and it's just missed it. And you've got to wait for it to go through the cycle again before it gets back to it. It's really annoying. How do we get the probability for this? How do you get the probability? How do we get the average for this? Well, we no longer call it average, we call it the,
mean.
don't even call it mean,
E.
the expected value. If we're rolling a dice, what do we expect to get on average? 3.5. You can't get a 3.5 because it's discrete data. So what do we expect? It's like cricket players. You know, they'll have an average like 57.31, but they can't get an average. They can't actually score at 57.31. So there's discrete data, but you get decimals and the average. Here's what it is. It's 1 times 1/6 plus 2 times 1/6. 3 by 1/6. Got to write the whole thing. 4 by 1/6. Please don't just switch off and go, oh yeah. I wrote 4 instead of 5. 6 by 1/6. So what have we got? I have bothered to write it. 1/6 plus a 2/6 plus a 3/6, which is the same as up there. 4/6 plus a 5/6 plus a 6/6. So if we wanted to, I could have written as 1 plus 2 plus 3 plus 4 plus 5 plus 6, all over 6, and it works the same. I've got mine, 3.5. What's what the formula is? Adding is called a sum. Have you seen sum symbol before? So capital sigma, we've said it before, haven't we? If I be fussy, it's like that, like that, like that. And that means sum. What's what it is? A px.
No, but it doesn't start at that age.
So my brain naturally wrote the 1 times, boys, my brain naturally wrote the 1 times a 6th, but people write it normally as a formula as px. So what have we got? The probability by that. Now really, if we be fussy, you go a little I there, and we want the I to go from where to where?
1 to 6.
1 to 6. So there's your formula for expected value. Now we just call it dx, which just means the
Expected value.
which is also the average or the mean. And that's your formula, and you could have just gone through and gone, well okay, it's 1/6 by 1, and then it's 2/6 by 1/6 by 2. Oh, I can't stop doing that stuff. And it's 1/6 by 3, and on it goes. When we get to continuous, we do the same thing, but instead of doing it discrete like this, we're going to do it as an integral. Okay, so the same concept applies. Next thing we go to variance, which is annoying, but for now, let's just get that into your brain. Done?